We've seen how series start out as this idea of, can I even add infinitely many things together? And the answer is yes, we do it all the time with decimal expansions. But more recently in this class, we've been interested in adding together infinitely many things, which aren't just decimal expansions. We have plenty of other formulas that we can now say whether or not those infinite sums will converge to a real number. Power series take this one step further, where the infinite sum is just one step in our formula, where we can supply some input value x, the infinite sum does its stuff, and we come back, we have some output, which gives us a function. So power series define functions. This is a very important point. Power series define functions, and not only do they define functions, oh boy, we get to make new formulas for new kinds of things, but they are actually very well behaved. When a power series converges, it will have properties that make it very nice to work with. So let us explore, what is it that makes a power series such a nice thing to work with? And then very soon we'll be close to saying that, in fact, a lot of functions that we know and love can be represented as a power series. So here's already a function, 1 on 1 minus x. It's a rational function. It's maybe not the most exciting rational function I've ever seen, but I know that this function is continuous, except for x equals 1. And I know that this function is differentiable, again, except for x equals 1. And it's got a vertical asymptote at x equals 1, and it's got a horizontal asymptote at y equals 0. But we know already that we can represent this function as a geometric series, so long as x is less than 1 in absolute value. So as long as x is between -1 and +1, the series converges. And we get this nice rational function. Well, what are the things that are nice about this function? It's continuous, it's differentiable. Those are true of the power series version as well. So we would like to understand, can we take some of these ideas about continuity and differentiability and apply them to the power series, right? Those are pretty standard qualities of a rational function. So it's not a surprise anymore that 1 on quantity 1 minus x is a continuous function, is differentiable, as long as we are sticking away from x equals 1. How much do those carry over to power series in general?